Yes, good morning, students. Today I am going to explain about the types of digital to analog conversion. Okay, in last video I have explained what is the digital to analog conversion in depth, how it is working. Okay, what and all digital data we supposed to use, how the digital data it is going to convert it as a analog signal. Everything I have discussed in last video, but today I supposed to explain the different methods or different types of digital to analog conversion by using different methods. Okay, how it is going to happen. Then, like in digital means DAC, we have four types. That is, first one is amplitude shift key. That is ASK. Second one is frequency shift key. Okay, we call it as FSK. Then phase shift key, we call it as a PSK. Then the all together, okay, ASK, FSK, and a PSK. Okay, these three are going to going to my making as one of the quadrature amplitude modulation, that we call it as a QAM. Okay, the QAM is, it is a combination of our amplitude shift key as well as phase shift key. Okay, we will discuss one by one what is ASK, FSK, and PSK. Okay, now I am going to explain the ASK. ASK is nothing but it is amplitude shift key. Okay, the amplitude shift key initially it contains, okay, first of all I am going to explain what is amplitude shift key. After that we will discuss how many types is there under this amplitude shift key. Okay, then what is the amplitude shift key? The amplitude shift key, whenever it is like we are going to implement the amplitude shift key, okay, during that time phase and frequency will be remain constant. Okay, during that time it is going to change or it is going to vary the amplitude. Okay, amplitude is nothing but peak value. Okay, it is only changes happens during the conversation. Okay, like changing the amplitude. Okay, but during that time our frequency and phase will be remain constant. Okay, how it is happen, I'll show it in the diagram. Then afterwards, in this amplitude shift key we have two types, that is binary ASK and the second one is multi-level ASK. Then what is the binary ASK? The binary ASK, it is like similarly it should be a amplitude shift key ASK. Okay, with the help of amplitude shift key we normally implemented by using the two set of levels. Okay, this is referred to as a binary amplitude shift key. Okay, this is nothing but on off key. Okay, this we call it as a short form hook. Okay, a binary amplitude shift key basically it is works on the on off key method, that we call it as a hook method. Okay, the peak amplitude of one signal level is 0. The other means the other is the same as the amplitude of the carrier frequency. Okay, carrier frequency also same, but during that time it is going to vary only the amplitude. Okay, how it is, I'll show it in this diagram. The next diagram I'll show how it is. See, you look at this diagram, this is the binary amplitude shift key. Okay, see, this is the data set I have given, that is 10110. Okay, like this um, these data set, okay, means each data. Okay, yeah, each data we call it as a bit rate. Okay, means one bit rate, like that how many bit rate we have? 1 2 3 4 5. Okay, see, this is what we call it as a bit rate is equal to 5, means it contain all 5 values. Then the baud rate will be 1 second. Okay, the within that 1 second is supposed to execute all the data or all the signals. Okay, then how we consider as how the frequency will be changed, sorry, how the amplitude will be changed. Okay, during the during that time frequency and phase will be constant. Okay, we will see here. Okay, how it is. See, this is the value. Okay, normally if it is 0 means no value. Okay, if it is 1 means, okay, it should be take the transaction, like that. See, if it is 1, yet it is going to generate the amplitude with the help of phase and frequency. See, here frequency will be equal, yes, there is no any changes, and phase also will be equal. See, this is the 0 degree phase, then it is going to end with the 180-degree phase. See, like that, phase and constant, phase and frequency will be constant, but amplitude will be may vary. Okay, see here, if it is 0, there is no not at all amplitude here. See, it should be nothing. Okay, if it is 0 means no value. Again, if it is 1 means yes, it is going to take the transaction. Yes, if it is 1, yes, it is going to take the transaction. If it is 0, no value or no transaction will be, means no frequency it is going to happen. So this is what our binary amplitude shift key. See, each signal or each data, it is going to produce the one signal element. Okay, then how we are going to implement. Okay, before we are going to implement, okay, we have to talk about our bandwidth. See, this is the bandwidth here. Okay, you look at this diagram, this is the bandwidth of our binary amplitude shift key. Okay, here have taken as a bandwidth is equal to 1 plus d into yes. Okay, then how it is going to happen here. See, our our bandwidth here proportional to the signal rate, means that is nothing but our baud rate. However, there is a normally another factor involved called d, which depends on the modulation and filtering process. Okay, the value of d is between zeros and 1. This means that is the bandwidth can be expressed as the shown, where s is the signal rate and b is the bandwidth. Okay, see, the d is the means the value ranges will be 0 and 1. Okay, whereas okay, s is the signal rate. See, this is the signal rate. Okay, and b is the bandwidth. Okay, so this is what our bandwidth. So now we call it as the bandwidth is equal to 1 plus d into s. So d is nothing but it is contain the value of 0 and 1. Means if it is like, if it is data is there or signal is there, well, it should be a 1. Okay, if it is no anything, means nothing will be there, is there is no any signal or any data, we consider as a 0. Okay, that value it is going to hold on our d. So 1 plus d means only one, only 1 second it is going to executed. Okay, many number of frequencies, so that bandwidth is equal to only one bandwidth plus the d means number of values into s. S is nothing but signal rate. B stands for bandwidth. See, this is what our bandwidth formula. See, this is what bandwidth is, B of ASK proportional to signal rate as well. So this is what I have told now. Okay, the same thing here. Then what is the implementation of binary ASK? See, the binary implementation of amplitude shift key, like it is going to taken here. Here, see, this is the diagram of our binary amplitude. Here, what is this? This is the data rate or digital value. Okay, see, it is going to convert it into the carrier signal. It's nothing but this is for normal, like how the carrier signal it is going to happens. Okay, so this is the carrier signal, and this is like which we modulated like with the help of carrier signal. Okay, they have given the data. Okay, how we are going to modulate it. So this is the modulated result. Then see how for like initially for practically how this output is going to generated, how it is going to happen. See, so by like with the help of this oscillator. Okay, then digital value, okay, it is going to multiple with the carrier signal. Okay, how it is, I'll tell you. Okay, so this is what here, the most important point here is the location of the bandwidth. Okay, the location of the bandwidth should be middle of the bandwidth is where frequency FC. See, this FC we call it as a carrier frequency. Okay, this FC we call it as the carrier frequency is located. This means if we have a band pass channel available, we can choose our FC so that the modified signal occupies the bandwidth. This is the fact of most important advantage of digital to analog conversion. Means we can shift the resulting of the bandwidth bandwidth, okay, the it should be available.